As a shortcut, we'll call it as LODs. And what are level of detail expressions? So we have three level of detail expressions. This will also fall under calculations. So the level of granularity of the data can be changed using this LODs. Let's say I'm using an LOD which is an include. I will be bringing some of the dimension which I'm not using onto the field inside my calculation. So the granularity of your data will be changed according to my LOD. So what is an include option? So it is used to consider more dimensions into your calculation, even the dimension is not used on your view. It says that you can use your dimension inside your calculation, and if you're not using that on the view, whatever value you're seeing over there on the view, this will consider this include calculation and whatever dimension you used inside your include dimension, and it will give you a result from this calculated field. So what is exclude? This expression will exclude the specified dimension from the view. Exclude cannot be used where there is no dimension at all. Okay, let's say this is an opposite of an include function. Like the meaning says, the word says exclude. You're using some couple of dimensions on your view and you're getting some value of like sum of sales. Let's say in the example of sum of sales, you're getting some value and you want to exclude some content or like one dimension from your calculation, but you do not want to exclude that on the view. In this case, you can actually use exclude and you can put the dimension inside of your calculation and say exclude. And we have one more called fixed. This level of detail expression will compute a value using a fixed specified dimensions. So opposite to include and exclude, fixed will calculate the value based on that particular dimension, whatever you used inside your calculation. It will not consider any of the dimensions you have on the view or any other dimensions out of the data. But it only sees whatever dimension you used in that fixed calculation and will calculate the measure from that particular dimension. So these are our LODs, and the next one would be bins and their uses. So what are bins? Bins are used to categorize measure value into different buckets. So what bins will do is they will create this regular intervals to the columns. Okay, let's take the example of if you are seeing a value for sum of sales for one particular region. In this case, you can simply consider that your region is creating some bucket for each value, right? If you just create a bar chart and you're using a region for sum of sales, you can simply consider the dimension as a bucket for each value. This region creating this level of detail, and it is bucketing up one range where the value is falling under the range. So bins are used to organize the measure values into discrete data point, and they can be used only on the measures. So whenever you want to create this bucket using a measure, these bins are used in that particular requirement. Bins are generally used to create histograms. Okay, histograms will be looking like a curve kind of visualization, and bins are mostly used in histograms. If you see in your quick visualizations tab, you will see a histogram over there and how it looks like. Let's quickly go back to our tool and see how these two are performed inside our tool. So first one for us is at the level of detail. So this LODs allow you to compute values at the data source level and also at your visualization level. Just remember this point whenever you're using this LOD, it will consider creating the values, the columns you're creating at the data source level and also the visualization level. It gives you more control on the level of granularity and you want to compute, because you're using some field whichever is not in the view, or you're using some field you're excluding some field which is in the view. Like Like that, it actually controls the granularity of the data. This one, in this session, we will be seeing how to use an LOD expression and how it is used in different scenarios, and we will also see the different types to create the LOD expression. We're on our full data and just navigate to a new worksheet. So I'm just dragging my region and also my sales. Okay, this is a simple view, and I'm just dragging my region to the columns. Okay, I've got this one and I'm simply converting them into a bar graph. Okay, let's map this. Okay, we have a simple bar graph with the region and the sum of sales. Now we will create a LOD calculation using include. For creating an LOD calculation, just go to Analysis and you can actually click on Create Calculated field. You can either go with this arrow mark and say Create Calculated field over here also. That is one more option to create the calculated field. So inside this calculated field, I'm going to use include. Use include as our LOD. So Tableau will throw up the syntax also for this include a part, and it will start with that flower bracket because this is the syntax of LOD. So we will create one simple calculation using this include. I'm just including my customer name and I'm bringing out the sum of sales. Please remember that LOD calculations should be aggregated, otherwise it won't take the calculation. It always should be aggregated. I have to give some name. It also throws you error if you just don't fill up any name, and it also will throw an error if there is already a field with the same name. So include a sales, I'm just giving include sales. So right now in our visualization we have sum of sales. Let's see how our sales will look like if we include the customer name also inside the sales, and we will see the average sales made by each customer. So for that, I'm just changing my aggregation level to average. So for this, if you compare these two visualizations over here, you can see the sum of sales and you can also see the average sales per customer in each region. So this one, how this calculation works is, it will go to each and every customer name because include customer name is there in our calculated field, and it will calculate the average sum of sales for each customer name and brings out the value, and that value will be aggregated into an average. So this average will show you how your sales are looking whenever you're seeing the whole sum of sales, and whenever you're seeing according to the customer, like for each customer, how is my average of sales whenever I'm looking at the region-wise region-wise view. So this is how you create a an LOD like using a calculated field. So there are other ways to actually create the LODs by simply dragging and dropping. You can create a fixed LOD expression without actually writing anything. You just have to drag and drop that particular measure on that particular dimension to get a fixed calculation. Let's see how we can do that. Okay, I'm just dragging my sum of sales onto my ship mode. Just click on create calculation field from here and you can write the fixed LOD. Because we clicked on the ship mode directly, the category will be taken into consideration inside our calculation field, and we can write our fixed calculation or include or exclude inside our calculated field. This is one way of creating the LODs from the category side. You just saw how to drag and drop the field into onto the ship mode to create a calculated field on the fixed basis. So fixed is like it will compute using a specified dimension without reference to the dimensions in the view. Like if you see here, I have region as a dimension in my view, and if you create fixed on the ship mode, it will not consider region at all. It will just give me the values of the ship mode only. Okay, let's see how to create fixed calculations on different views. Okay, I'm just dragging region. Let's go with the hierarchy so it will be understood better. So I'm also dragging state and I'm saying sum of sales. So what Tableau is doing here, it is first going to the central and it is later going to the state, and it is giving me all the values based upon the state values, right? So what if I just write a calculation based on only region? Okay, let's write the calculation field based on region. I'm just going to the region, create calculated field. So region has been come up here already, and I will say fixed. Just double click on this, it will create the syntax for you, and the syntax for is colon and sum of sales. Okay, I'm closing my floor bracket. And if you want to see the syntax in here, you can actually go up and see the syntax by just clicking on fixed. Okay, fixed region. So how this will show the values? You saw the values of how they are populating based upon the state, right? And what if I just say fixed region? See, the values completely are displaying same value for all the states. That means the fixed calculation only computing the calculation based upon the region, and it is not considering any other dimension on your view. So this one will throw up a value from the central as this value 501. Whatever you have it over here, it will show only that value, because inside your calculation you just wrote fixed region. So that calculation only consider region over here. In the same scenario, what if you use include in this scenario, and if you just say, okay, include my region as well. Let's go with that. If I say include but not fixed over here, so what Tableau will do is it will also include region and calculate sum of sales. This is the same thing what we saw before, right? Like whatever we dragged on the starting version with region, state, sum of sales. So the level of detail picked up central and also state. So in this case, there is no use of LOD at all. You can simply drag sum of sales, but I just want to show how this include calculation will work on in the same scenario. It will go to the region, include region into our view, and pick up the sum of sales. This is how the values look when you use an include calculation instead of a fixed calculation in this scenario. Let's see one more example for include calculation. Okay, I'm just dragging segment sum of sales, and I'll just show a visualization for it. Swap it, and I'm just seeing some vertical bars. Okay, right now our visualization is calculated based upon segment sales. What if I want to include something else which is not there on my view? Okay, let's say I'm including the same thing, region, into my view. As we already wrote at the calculated field, and I'm just using the same thing. Okay, so I just dragged region include. It's not fixed, it's actually include inside the calculation. What happens when you drop include region into your calculation? So right now it is showing the same values. Why? Because the segment is already there in your detail. The segment is also included in your calculation over here. So what if I just so this one, okay, this one is actually going up with each region and giving us the number, but there is no difference at all with the sum of sales and fixed region, include region, because the granularity is not changing at all. Okay, let's take a different example. Okay, let's see. Okay, let's say we'll take the include a customer name. So this one should actually bring up the customer name into our scenario, and it should give the sum of sales. It will also be the same whenever you're dropping onto your view, because the customer name in that particular column will be going into that particular segment only. So the level of granularity will not change, as we have seen before. The region also, the level of granularity did not change, because including region also it will throw up the same value. Okay, let's take, how about we take an average of the customer names sales. Okay, and okay, that's it. We are taking an average of this complete calculation. So whatever we're doing here is we are including our customer name and we are picking up the average sales of each customer name, because if you go with the sum, it will throw up the same value as the granularity will not change. But if we see the include sales in this part, so the sum of sales is totally 1161401 in that particular consumer segment. But if you just go with each customer name inside and if you pick up the average sales that each customer made, the average one is actually coming out as 2839. So this is how you see the average trending in your sales in each segment. Even though if your sales are high, the average can be lower if you consider consumer and corporate. The corporate average is coming up high because we went to the level of granularity customer name. So it is bringing up the customer name up. It will go with each customer name and see what sales is doing, and it will pick up with the average of that. So the corporate is having the highest average than the consumer segment. Even the sales are low, the average is high. You can check it like this with each customer, and if you can easily compare with this include statement. Let's move on to our last one, exclude. So what will exclude do? What is the main function of exclude is it will exclude some values on your view. If you have some value on your view and if you do not wish to see that value onto the measure one, you can just say exclude this and give me the value. Okay, let's see how that works. Okay, I'm going we will do the same thing which we did for region. Right now we have done a region wise sales, right? Okay, let's see this. And we know how it acts whenever we do a fixed one or whenever we do an include one. What it will do when I say exclude a region, in this state we have to exclude a state because region is the main one. It will not show you the right values. Okay, I am saying exclude state. For the easy understanding, I'll just rename it to LOD. So whatever we have right now is it is bringing up this value based upon center and region and the state, right? What happens if I just exclude state and I want to look at the sales? See, it excluded state completely on the view. Your view has a state on inside, and the granularity should change according to the state, but it is not doing so. It is only bringing and showing our central values, and it is throwing the same value around. This is the vice versa of whenever you do an include statement, like fixed statement, like whenever you do a fixed on only region with any of the other dimensions on the view, you just get this part, right? Which is the same thing with the exclude. I just excluded state from my view and the calculation completely came from center. In this case, what if I have one more dimension on my view? Let's say I'm just trying segment. See, the value changed. So what it is doing right now is it is going to the segment first and it will come back to region, but it will not consider state at all. It will not consider state at all. And this one is only based upon these two values. If you just use the same thing with fixed, how does it look like? So I'll just say only on the region, nothing else, fixed only on the region. How does it look like? See, value, even if you have segment, even if you have state in your view, it is only considering region and the value is coming up only from the region. This is how you can use this LODs in different ways, and you can really solve some tough problems, like if you want to see the average sales happened in all over your geographical content, irrespective of whatever dimension on the view, you can basically go with this. Or else if you want to see how many quantity you have sold in one particular segment to compare it with other dimensions, and you don't want to mess up with the dimensions on your view, changing your aggregations, then you can go with this LODs, like you can see some average value coming up to compare with that every time. So this is all about our LODs. I just want to repeat on the filters we have already discussed. There is an order of operations for the filters, and we discussed that we will be going in detail with the filters order of operations in the coming sessions previously. And here I want to just remember, I want to point out that the fixed LOD filter will come after the context filters, and the include exclude LOD filters come after the dimension filters. So the order of operations will be applied like that. Fixed applications are always coming after context ones, in between the context and a dimension filter. So it is always before the dimension filters, the fixed ones are coming up, and include and exclude after, in between dimension and measure. That means before the measure filter. So the order of operations is like really important to remember, and I want to point out here that we are all talking on LODs, and these LODs can also be used on filters, and this is how your order of operations will consider on the data granularity whenever you're using the filter. Okay, this is all with the LODs, and we will be moving with our next topic, bins. So any discrete field in Tableau, so all the discrete fields in Tableau can be considered as set of bins. For example, if you want to create a view with profit, and let's take the view of profit and state, you can consider each state as a bin. So what state is doing right now here? It is picking up the value particularly related to the state, and it is creating a bar for you. That we can consider this as a bin. And if you want to see this values for profit assigned in the bins without any reference to the dimension, like what we have here, the profit is actually referenced to the state. But if you want to point out something without any reference to the dimension, then you can create bins. So how to create a bin? When you create bins from a measure, this will create a new dimension for you. And to create bin, you have to go to whatever measure you're thinking about to create bin. Let's create a bin on sales and create bins. So remember, you can create bins only on measures. So this is the default naming which Tableau gives us, and this is the size of the bins it says. You can even suggest the bin size for Tableau, but this is the bin Tableau suggesting. Bin is basically the range. How many values should fit under that particular bin. So in the sales, it will give you the minimum value and the maximum value. So right now your sales measure has a minimum value 0 and the maximum value is 22,638. And what is the difference between these two is over here? Count D is basically the unique values you have in that range. So from 0 to 22,638, how many unique values do you have? This is the count D of that. So if you create a bin, what it does is it will create a discrete value here. See, if you see here, the sales bin is actually a discrete value. It created a range of range of values inside it. When you add a binned dimension to the view, each bin acts an equal sized container that summarizes the data for this particular set of values. Rows or column headers are created where each bin label designates the lower limit of the range of numbers that is assigned to the bin. So how bin will act when you add this bin onto the view? Let's see that. So I'm just let's see the bin we have just created. So these are the values coming under bin. It actually started with 0. If you just remember, the bin size stated as that it should be 447 according to the value we have. So it created from 0 to the highest value based upon the bin size 447. Okay, let's take our bin size and just convert into continuous. So this is how we see when we just have only bin on that, because it does not have any measure to allocate in that particular bin. Right now what I'm doing is I'm just taking my sales bin and I'm just allocating some values inside my sale bin, and it will look like this. So this is kind of range from the 0 to 447, these many values you have under it. So right now my sales is an aggregation of sum. So I want to look at what count of sales are done in that particular bin. So in my 0 bin, that means it doesn't have any sales, 0 bin, how many count of sales I have, like how many 0 sales I have. This is 8,662 sales with a 0 bin coming up. And next, in my 447 bin, how many count of sales do I have? It is 777. This is how it will allocate the values according to the bin bucket. This we call it, this kind of bins, we use it for histograms, and we will create each buckets for each value. Right now we are just seeing the count of sales in my sales bin which I created, and my bin size is 447. So in that particular range, how many count of sales I have? Count of sales is just going like each sale one count. So all that particular count will be aggregated and it will be showing up like here. In this bin, this many sales I have, and in this bin, this many sales I have. So this is how a bin is used. And if you want to like create something more out of your bin, and if you want to point out your average sales also in the same bin, let's just drag the average sales to the color and see the color is actually allocated according to the sum right now, but it is going with the average sales over here, and we will be seeing the average sales in particular colors as well. This is how you can point out, like you can drag different things into your detail value. Okay, let's just see how many average sales I've got in each bin, and also let's just say, so based upon maybe the region, how many average sales I have, it will actually created a stacked bar out of each bin. Each mark you have it in region, because region we have 4. This one will be divided by 4 and it will be showing average sale for each region. So this is how you can create visuals from bins, and you can drag as many as dimensions into your view also to show it more insights from your data. So this is all about bins, and we will quickly move back to our presentation. So the summary for the whole session is we just went through the filters and what do we have in filters, and we also saw what type of filters are used in different case scenarios. And we learned a bit more about context filter, because context filter is a unique and independent filter, and all the other filters are dependent on it. Context filter is one kind of a filter, and it is important. We just saw how to use it, where to use it, etc. We discussed about calculated fields and aggregations, how to create calculation fields in different ways, what kind of aggregations we have in a quick drop down option in menu, and what kind of syntaxes we have inside the calculations, how Tableau will easily show that in that calculator editor, how to write the syntax, what is the explanation, write with an example, etc. It's like so easy understandable, and common users are commonly used ones in our calculations. We went with the simple ones like subtraction, addition. We also went with if else clauses, etc. And what kind of LODs we have, level of detail expressions, let's say, when to use them. We have 3 kinds of them, and when to use them, how they will behave in different kinds of scenarios, and what are the table calculations we have and how to use them. And we as our last topic, we spoke about bins, how bins are used in our calculations, how bins are used to differentiate each bucket if we have a measure, and how to allocate that measure to each bin, etc. So this is a complete summary of this session, and thank you so much. We will see you in the next session.